The goal was simple: make the viewer a part of the scene. A variety of high-end techniques were designed with the sole purpose of creating an immersive, detail-rich, real-time environment. And while these methods are past convention, they are implemented efficiently within the current specs of the most cutting-edge popular video game engines. Welcome to the Toy Shop. A novel post-processing rain effect was developed to simulate multiple layers of raindrops with a compositing pass over the rendered scene. Motion parallax for raindrops is created through projective texture reads. The rooftop puddle was created by combining many different layers of detail with a dynamically generated ripple simulation. This implicit integration for the fluid dynamic simulation is calculated entirely on the GPU. The raindrop particle collisions generate multiple interacting ripples in the puddles throughout the scene. We simulate raindrops splashing by colliding individual particles with objects in the scene. An animated high-quality milk drop texture sequence was used for the raindrop splashes. To generate raindrops falling off objects, we use physics-based particle systems with stretched normal map quads. The stretching based on particle velocity created the illusion of motion blur. The illumination from the lighting system accurately affected refraction and reflection of the droplets, adding further realism to the scene. For the street puddles, a texture masking method was used to control puddle placement and depth in order to minimize the complexity of the street geometry. The street puddles utilize the same GPU-driven ripple simulation as the rooftop puddle. An offline raindrop simulation system was adapted to the GPU to render water droplets trickling down glass panes in real time. This system allows us to replicate the quasi-random meandering of raindrops due to droplet velocity, mass, and surface tension. Parallax occlusion mapping is one of the most complex rendering techniques in the Toy Shop demo. This efficient algorithm provides a real-time, per-pixel ray tracing solution for inverse displacement mapping, using dynamic lighting, soft shadows, self-occlusions, and motion parallax. This technique generates smooth LOD transitions without visual artifacts and maximizes visual quality by dynamically scaling the sampling rate of the parallax occlusion mapping computations. Each technology in the Toy Shop demo adds detail to the scene. Each additional detail changes the way you experience the environment. This attention to detail seduces the viewer and delivers a lasting impression of the limitless expression of real-time graphics.